Good morning, students. Today in the video lecture, we will going to get the knowledge about serializability, conflict, and view serializability. And it's a very important topic in AKGEC syllabus, and lots of numerical also come on this conflict and view serializability. So continue with it. We have learned various types of schedules. There can be a schedule can be a serial schedule, non-serial schedule. Non-serial schedules can be categorized into serializable schedules and non-serializable schedules. Serializable schedules can be that we are going to discuss in our today's topic: conflict serializable and view serializable. Some non-serializable schedules like this, they can be recoverable and non-recoverable. In the recoverable schedules, we discuss about the cascading schedules, cascade-less schedules, and strict schedules. So, first we start with the serial schedules. What is a serial schedule? Schedules in which the transactions are executed non-interleaved, means they are not performing the transaction in parallel. A serial schedule is one in which no transaction starts until a running transaction has ended, are called serial schedules. Like we have two transactions, T1 and T2. If T1 some instructions are going on, only after this has finished, T2 will get start. It starts from after only this ends. Okay, this type of transactions are, or this type of schedules are mainly called serial schedule. Here we see T1 RA means read the variable A, write on A, read on B. These are the transactions instructions in the transaction T1, and these are the instructions in the T2 transactions. This is going to be started only when this ends. Okay, where RA denotes that a read operation is performed on some data item A. This serial schedule, this is a serial schedule where T1 and T2 execute in an order. When T1 finished all its transactions instructions in a schedule, then T2 will get started. Non-serial schedule. This is a type of scheduling where the operations of multiple transactions are interleaved. Means one starts, then second starts, then third starts, then continuing with the first one. We can say if we have T2, T3 and T3, this read something, this read something, this read something, okay, of A, B, or in these schedules, this can be started again, like we call read B or write B. This type of transactions are called non-serial schedules. The transactions are executed in a non-serial manner, keeping the end result correct and same as the serial schedule, and that non-serial schedule should work as the serial schedule only, means but their execution of instructions can be at interleaved. Unlike the serial schedule, where one transaction must wait for another to complete all its operations in a non-serial schedule, whereas the other transaction proceeds without waiting for the previous transactions to complete. In a serial schedule, one has to wait. Once one finished, then only it will start, but in non-serial, it will start at any time. It can be of two types, mainly serializable and non-serializable schedule. It can be divided into serializable and non-serializable schedule. Serializable schedule. This is used to maintain the consistency of the database. Why we need serializable schedule? To maintain the consistency. So, the database should be always in consistent state. It is mainly used in non-serial scheduling to verify whether the scheduling will lead to any inconsistency or not. So, non-serial schedules are parallel in nature, interleaved in nature, can start once one instruction is completed or not completed. It starts with the second instructions, second transaction, and the third likewise for the many transactions. So, a serial schedule does not need any in a serial schedule we do not need any serializability check, because it follows a transaction only when the previous transaction is complete. So, it has no problem, but in non-serial schedules we have a problem that whether the database remains in consistent state or not. The non-serial schedule is said to be in a serializable schedule only when it is equivalent to a serial schedule. So, we have to prove it, like if it behaves like a serial schedule, then only we can say the database will remain in consistent state, and we know that a serial schedule, in a serial schedule every time the database will be in a consistent state. Since concurrency is allowed in this case, multiple transactions are executed concurrently in non-serial schedule. A serializable schedule helps in improving both the resource utilization and the CPU throughput, as a resource should not wait for one transaction to complete, it can be used by another transaction. So, utilization of the resource will be increased. So, we have two mainly type of serializable check or type. We have conflict serializable and view serializable. A schedule is called conflict serializable if it can be transformed into a serial schedule by swapping some non-conflicting operations. Two operations are said to be conflicting if this condition has to satisfy. That means they belongs to different transactions like T1 and T2. These are two transactions. If they belongs to T1 or T2, they operate on the same data item, like T1 operates on TA and T2 also operate on TA, then it should be it can be, we can check for conflict serializable, and at least one of them is a write operation. So, here there is no conflict, as we see these two are only the read type of instructions, but if we write A, write A, write A, then these are conflicting, these are conflicting. Okay. So, these three conditions should be met. They belongs to different transaction. This read A, write A belongs to different transaction. They operate on same data. They operate on same data, and at least one of them is a write operation. Whereas a view serializable is a, if it is a view equal to a serial schedule, that is no overlapping transaction take place, then we can say a schedule is a view serializable. Conflict serializable is a view serializable. This point has to be noted. A conflict serializable is a view serializable, but if the serializability contains blind writes, if the serializability contains blind writes, then the view serializable does not be conflict serializable. A conflict serializable is always a view serializable, but if the serializability contains blind write, then it does not be a conflict serializable. So, understanding more about the serializability. Serializability is a concept in database that ensures the correctness of concurrent transaction. So, when transactions are working in concurrent states, then we have to check whether they are consistent or they are correct. They leave the database in a consistent state. So, this serializability will check whether the database remain in a consistent state or not. So, when multiple transactions are executed at the same time, serializability in DBMS ensures that their combined effect on the database are equivalent to the effect of running them serially, one after the other. So, the same type of transaction we have, like two transaction T1 and T2, and they are working non-serially, but their corresponding serial schedule should have some impact on a database. So, the non-serial schedule should also have the same effect on the database. It is guaranteed that the set of transaction is executed perfectly over numerous items. We have to check all the items whether it is working on all the data items. Serializability works by scheduling transaction in the order in which they are executed. So, it also check what order should be followed, and it schedule the transaction in the order in which it should work, so that it leaves the transaction in a consistent state. A serial schedule means the transaction take place serially, that is one after the other. We already discussed that serial schedule should be work only after one has finished its work. This leaves no place for inconsistency within the database. So, if it works like a serial schedule, there is no inconsistency remains in the database. Serializable schedule. A serial schedule is a sequence of database actions like read and write operations that does not violate the serializability property. What are the serializability property? This property ensures that each transaction appears to execute atomically and is isolated from other transactions effect. A serializable schedule always leaves the database in a consistent state. Like we have an example T1 and T2. Suppose T1 reads data item A, then writes to data item B. Similarly, T2 reads data item B and then writes to data item A. If these two transactions are executed concurrently, it may lead to inconsistency in the database. Why? Because it's T1 reads data item A, but it's writes to data item B, whereas the T2 reads data item B and then it writes to data item A. However, if these two transactions are executed serially one after the other, then it will not lead to any consistency. So, if it takes the serial scheduled way, then there is no inconsistency, but in a non-serial way, it will create some inconsistency. So, we have two types of serializability: conflict serializability and view serializability. Schedule is called conflict serializable if it is transformed into a serial schedule by swapping non-conflicting operations. So, what are conflicting statements and what are non-conflicting statements? Conflicting statements are mainly, we have discussed, like if one transaction is reading a data item B and another one is writing a data item B, then these are the conflicting statements. As this belongs to two transactions T1 and T2, and one of them is they operate on the same data item, that is A, and one of them is a write operation like we have here. Besides, all other are non-conflicting operations. Two operations are said to be conflicting if all the conditions are satisfied. They belong to different transactions, they operate on the same data item, and at least one of them is a write operation. Here is an example. We have a schedule S1 where R1 yani read A, the transaction T1 reads A, then it writes A, then transaction 2 reads A, then it writes A, then T1 reads B, write B, and T2 reads B and write B. So, there are some conflicting operations pair like R1A and W2A, because this is a read operation and this is a write operation, and they are operating on the same data item because they belong to two different transactions at the same data item A, and one of them is a write operation. Similarly, this write operation on A and this write operation on T2 transaction, and W1A and R2A. This is also, pairs are also conflicting. On the other hand, R1A and W2B. These are pair of non-conflicting because they operate on the different data items. So, these instructions are non-conflicting, whereas similarly W1A and W2B are also non-conflicting because they also operate on the different data items. If OI and OJ are two operations in a transaction and OI is lesser than OJ, means OI is executed before OJ, same order will follow in the schedule as well. Using this property, we can get two transactions of schedule S1, like we have a schedule R1A, W1A, R1B and W1B. In a T2 transaction, we have R2A, W2A, R2B and then write B. Possible serial schedules are T1 to T2 or T2 to T1. If we execute them non-serially, then also their serial equivalent can be T1 to T2 or T2 to T1. Swapping non-conflicting operations R2 and R2A and R1B and S1, the schedule becomes, these are non-conflicting statements. If we swap those instructions, we can rearrange the schedule in a way R1A, W1A, R1B, W2B, W2A, okay, R2A, W1B, R2B and W2B, means transaction write on B. Similarly, swapping non-conflicting operations, we swap the non-conflicting instructions only. So, the transaction can be given as this, that read, write, these are done by T1 transaction, and R2, W2, R2 and W2, and means read, write on A and B data item. It can be shown as a serial way, means here we can clearly say that T1 is executed and after that T2 is executed. So, TS12 is a serial schedule in which all operation of T1 are performed before starting any operation of T2. Since S has been transformed into a serial schedule by S12 by swapping non-conflicting operations of S1, S1 is a conflict serializable. So, we can prove that it is a serial schedule. It is behaving, their output is behaving like a serial schedule by swapping non-conflicting statements. We can also check it from the way we can develop a graph chart. In graph chart also we can see that whether it is a conflict serializable or not. So, we take another example as to R2A, W2A, R1A, read A, read B, write B, read B and write B. Two transactions will be like R1A, W1A, R1B, W1B, or we can say T2 can be read A. These are the instructions executed by T2 transaction, write A, read B, write B. So, possible serial schedules can always be like if we can use T1 to T2 or T2 to T1. The original schedule is as mainly it is given. This is the original schedule, the same. Swapping non-conflicting operations R1A and R2B in S2, the schedule becomes, here also we say that R2 is executed before T1. This T1, this is T2 transaction and this is T1 transaction, but it is not. Swapping some non-conflicting statements, this is not serial schedule, but this is a serial schedule. Similarly, swapping, here we have to swap non-conflicting statements W1A and W2B in S2N, the schedule becomes S22. That is, swapping of non-conflicting statements can lead you to the schedule that is in a way serial schedule. In schedule S22, all operations of T2 are performed first, but operations of T1 are not in order. The order should be R1A, W1A, R1B, W1B. So S2 is not conflict serializable. So if we have that a transaction that transaction should be follow the order like T1 T2 or T2 T1. If we are following the order T1 to T2, then this schedule is not working in that order. Conflict equivalent, two schedules are said to be conflict equivalent if when one can be transformed by another by swapping non-conflicting operations. In this example, we have seen S11 is a conflict equivalent to S1 and S1 can be converted to S1 by swapping non-conflicting operations. Similarly, S11 is a conflict equivalent to S12 and so on. If it is working in a way a serial schedule work. Although S2 is not conflict serializable, still it is conflict equivalent to S21 and S21 because S2 can be converted to S22, S21 and S22 by swapping non-conflicting operations. The schedule, what we have to note is the schedule which is conflict serializable is always conflict equivalent to one of the serial schedule. As one schedule discussed above, which is conflict serializable, is equivalent to the serial schedules T1 and T1 executed first and then T2 will be executed. So what we have the advantage of conflict serializability? Consistency. Conflict serializability ensures that the result of the transactions are consistent with the order in which they are executed, and the order should be maintained. Order should be in a way the serial schedule work. Correctness. Conflict serializability ensures that the execution of a transaction is correct regardless of the order in which they are submitted. Whatever the order they have submitted, but should be correct in the sense. Reduce overhead, because conflict serializability reduce overhead by eliminating unnecessary locking and other conflict resolution mechanisms. So if we are working in a serial schedule, it locks the resources, but conflict serializability helps unnecessary locking of removes the unnecessary locking of the resources. Improved concurrency. It improves the concurrency by allowing transaction to execute simultaneously without conflicting with each other. Disadvantages are also there for the conflict serializability. Complexity are there, can be complex to implement, especially in large and complex database. For bigger database, it can be a complex task. Reduce performance. It can also reduce performance, introducing delays and overhead due to locking and other conflict resolution mechanisms. So it has to lock something to work for the transaction in concurrent way to make that transaction log some data item. So it has reduced the operations performance of the system. Limited concurrency. Conflict serializability can limit the degree of concurrency in the system because it may delay some transactions to avoid conflicts. To remove conflicts can be we have to remove the conflicts. So the concurrency is limited to some part. Increased overhead. Conflict serializability requires additional overhead to maintain the order of the transaction and ensures that they do not conflict with each other. So this can be also the order. View serializability. A schedule is said to be view serializable if it is a view equivalent to a serial schedule, like we have in a conflict serializable. where no interleaving of transaction is possible. Why we need a view serializability? There may be some schedules that are not conflict serializable, but still give the consistent results, because the concept of conflict serializability becomes limited when the precedence graph of a schedule contains a loop or cycle. So, to detect whether the schedule is conflict serializable or not, we used to draw a precedence graph, which shows, if the precedence graph shows a cycle, that means it is not a conflict serializable, means it cannot be changed into a serial schedule, but still it can be a it will be in consistent state. So, those type of transactions or schedules which are not conflict serializable, but it can be a view serializable. So, here in such a case we cannot predict whether a schedule would be consistent or not. We are not sure whether it is consistent or not. As per the concept of conflict serializability, we can say that the schedule is conflict serializable, means serial and consistent if its corresponding precedent graph does not have any loop and cycle. For the conflict serializable, we always say when there is no cycle in the precedent graph, then it is conflict serializable. But what if it is having a loop? How can we say it is not it will not be in consistent state? We are not sure about it. So, if a scheduled precedent graph contains a cycle or loop, but it also giving a consistent result, so this type of category, this type of transactions comes into the view serializable case. To address such cases, we got the concept of view serializability, because we did not want to confine the concept of serializability only to conflict serializability. So, understanding view serializability, we have mainly these three transactions T1, T2, T3. So, here we say A is 100, it is reading A, then T2 it is subtracting something from A and it writes A. A equal to 1 A minus 40, it writes A, then it writes also reads A, T1 also subtracting something, writing on it. Okay, here it is also writing something. So, it's what will be its conflict, that precedence graph? We can say this will be the precedence graph where T1 to T2, T1 to T2, because here it is writing something, okay, here it is writing something, okay, and so there is a line from T1 to T2. Why it is T2 to T1? T2 to T1, because this also writes something and belonging to the you can say this, you can draw this T2, T3. Alignment is not right. A is equal to 100. We have read A, then this T2 is doing some write operation. A is equal to A minus 40 and it is writing A, then it is writing A also by doing A minus 40. Okay, this is also writing A, then this also writes A, this also writes A is equal to A minus 20 and it writes A. Okay, so here the precedent graph can be T1 to T2, T2 and T2 to T1, okay, T1 to T3, T1 to T3 we have seen, okay. For this T1 to T2 and T1 to T3, For this, T2 to T1 and T2 to T3, T1 to T3. Okay. For this, we have already T1 to T3 already marked. So, this will be the precedence graph of this transaction. Mainly, this is the correct transaction. Here some alignment is missing. So, the graph, the above graph contains cycle or loop, which means it is not conflict serializable, but it does not mean that it cannot be a consistent or equivalent to a serial schedule. It may or it may be, we are not confirmed. So, what we will do? We will check whether it has a blind write. Whether we have to check whether there is a blind write available. In this, here it is a blind write. Okay, it is T2 is not reading anything, but it is writing the A. So, it can be categorized into a view serializability. To check for view equivalence, we have to check mainly three conditions. First is who has done the initial read and who has done the final write and who has done the intermediate reads. So, it should be equivalent to a serial schedule with these three conditions. If any serial schedule is available with the same scheduling, like if a non-serial schedules in a new schedule T1 is do the initial read and T2 do the final write, T2 do the final write, and all intermediate reads are in an order of T1 to T2. Then we have to find a serial schedule that follows the same type of order. If we get those order, then we can say that this type of schedule is a view serializable. So, we have another transaction. We have seen this. If we do swapping among some transaction operations, so our table will look like this: T1, T2 and T3. We follow T1, T2, T3. We can use, this is a serial schedule. The table can be like this. The precedence graph will be having no cycle. Now, we see the precedence graph of the second table does not contain any cycle or loop, which means it is a conflict serializable equivalent to a serial schedule. That means it is in consistent state, and the final result is coming the same as the first table. So, in the above example, we understood if a schedule is conflict serializable, we can easily predict that it will be equivalent to a serial schedule, can be a consistent and also a view serializable. But if it is non-conflict serializable, if it is a non-conflict serializable, then maybe there are some loop. In this situation, we cannot predict whether it is consistent or serializable or not. As we look in the above example, where the precedence graph of schedule S1 was giving consistent result equivalent to a serializable result of a schedule S1 dash despite containing cycle or loops. So, to address the limitation of conflict serializability, concept view serializability method came to the picture. So, we have another questions. So, this is a schedule. First, we have all to make a table for a better understanding of a given transaction, that is T1, T2, T3, T1, T2, T3. So, these are the instructions given. We can have a precedence graph for it, see to check for conflict. For view to check for view serializability, first we have to always check the conflict serializability. So conflict serial, we have to make a graph T1, T2, T3. So read and write operation, then T1 read, T1 to T2, there is a arrow, and T1 to T3 also, T1 to T3 also there is a graph. Then we look for T2, T2 to T1, T2 to T1, there is a present graph, and T2 to T3, T2 to T3, there is a present graph, and T2 to T3 again we didn't have to mark arrow again. In T3, T3 to T1, T3 to T1, T3 to T1 is also there, and okay, finished. Then T1 to T3, T1 to T3 is there. So there is a loop. We can clear that this is a not conflict serializable, not conflict serializable. So if it is not conflict serializable, we can say this is not conflict serializable, but have to check for the view serializability. So to check for view serializability, we have to check first that whether this schedule contains a blind write. So we can clearly say that there is a blind write. Blind write means it is not reading something, and without reading anything from the previous transaction, it is writing by itself. It's only writing the transactions, writing the instructions or data item without reading that data item. So first we check whether it is conflict serializable or not, because if it is conflict serializable, so it will also be a view serializable. So we will make a precedent graph for the schedule S dash, and here we check whether the schedule contains any blind write. We found that the schedules contains a blind write, as we have already seen in transaction T2. Hence schedule S may or may not be a view serializable. So we will look into another method, because if it does not contain any blind write in the transactions, we can surely state that the schedule will not be a view serializable. But now we will draw a dependency graph that is different from the precedent graph. Here we have already checked this graph. Transaction T1 first reads data item A, and transaction T2 first updates. So there is a graph we have already seen in an example. So now there is a task for you that which of the schedule is a conflict serializable or not. I should go through these 4 schedules, 1, 2, and 3, and 4. So I will do here the first part, and you have to perform it the next 3 parts. So in this we have 3 transactions, as we say R1, R3, W1, R2, W3. So we have 3 transactions are there. So we build a T1, T2, T3, where R1 X, and it is reading X, then R3 X, this is reading X, then it's writing X. Okay, here it is reading X, and then it is writing X. Okay, we are writing X. So we have to draw a precedent graph for this. Precedent graph can be T1, T2, T3. So we check for T1 are read, no conflict, read, no conflict, read, write, conflict. So R1 to R2, R1 to T1 to T3, T1 to T3, there is a arrow mark. Then we check for this transaction T3 to T1, T3 to T1. Clearly there is a loop. You see, clearly there is a loop. So why we should waste our time to further do the making of precedent graph. So we are clear that this is not conflict serializable. Okay, so that's all for today. You have to next 3 instructions should be calculated for to check the whether this is a conflict serializable or not. Thank you.